Hi everyone, welcome back to my YouTube channel. Well, in today's lesson we are tackling a new course which is known as your STA304, and in full it is your regression analysis. I'm sure you might be asking yourself that since it's regression analysis, what's the difference between this course and the one that we did in second year? So your STA304 is a continuation of what you covered in STA204, but we will get to that when we are now speaking of the prerequisite. So in today's lesson, what is of interest particularly is for me to give you an insight into the course, where we just have to do an overview, so that when we start tackling chapter 1 all until we get to the end, at least you've got an idea from our introductory lesson that this is what was expected of you to know, and most likely what are you going to face as challenges later on. Then also need to let you know the textbooks that we're going to be using. I will also speak on the CA composition, which hasn't changed. Then we will tackle your prerequisite, which is what I'd mentioned earlier on, to say that what is the difference between this course that you're doing now and the one that you did when you were in second year. And then we're going to have a task, and straight after that we will be done with today's business. So just going straight into the overview of the whole course. One thing that you need to note is the course has been put into 3 segments. That is to say, there is the simple linear regression part, which is I like to take this as we're just going to run through it because we covered everything when we were in second year. So that is your STA204. So we did this, but we're just going to do a little recap and then move it over to your multiple linear regression, where we are now going to be speaking to the theory behind it. We also need to mention the satisfactory conditions. How do you build the model? Are there any abnormalities that you need to keep in mind? Bearing in mind that all these abnormalities, for you to know them, I need to know. So you need to know the assumptions that have to hold for it to be treated as a multiple regression model. So we're only going to tackle on the 3, that is your multicollinearity, the autocorrelation, and lastly your heteroscedasticity. Then the last segment for the course is going to look into your polynomial regression. That is what you need to know. And then with regards to the textbooks that you are going to be using, I'll prefer that we use Douglas C, the Applied Statistics and Probability for Engineers, and Applied Linear Statistical Models. I'll try and upload the very 2 books onto the portal. Then going on to our CA composition, note that it still hasn't changed. It still contributes 40% to your overall mark, and the exam is going to contribute the 60%. Maybe that will change later on because we're still trying to observe COVID and all its regulations. If you don't find yourself having to write the examination, it means your CA will now come down to 100%. Meaning to say that we are going to still have the 2 assignments and 2 written tests. The dates for this that will be communicated in advance, or rather in due course. So proceeding to our prerequisite, these are the things that you still need to keep in mind, like what is simple linear regression, the simple linear regression equation that governs the calculation, how you get to find your beta naught and your beta 1, and what are the uses of your regression analysis. You still need to know those 5 major purposes that we spoke about in second year that are all encompassed on the prediction, variable screening, explaining a system variables, the inference, and planning and controlling. So you still need to go back to your notes and get to find out what exactly is it that we spoke about last year. Then not only do you need to know that, you also need to find out how we were calculating the ANOVA, and finding out that do the variables of concern, do they fit into a simple linear regression model? How adequate is the model? How do you even carry out the ANOVA? So those are the things that I know that as statisticians we tend to forget as time goes by. So you need to look into that as well. Speak to your confidence intervals. What are confidence intervals? How do I calculate them? What is the interpretation of this? I know we did also tap into our multiple regression just a little bit. So those are the things that you need to just go back, check. If ever you've got any questions that could still be lingering, I think this is where we're going to start off in our next, I think in the next 2 lessons, where you just need to raise those questions up so that we try and clear all the confusion from last year before we proceed into this year's business. So that is on the prerequisite side. So you note that everything that we did in our STA304, it's going to be feeding onto the current, that is your regression analysis. So I am pleading with you, please just go and check your notes, or rather have your notes with you at all the time, at all costs. So once you have made the effort to go through the stuff that we did last year, this is one example that I would want you to look into. See if you can answer the questions that do follow. So the question reads, it is difficult to determine a person's body fat percentage accurately without immersing him or her in water. Researchers hoping to find ways to make a good estimate, they immersed 20 male subjects and then they measured their waist and they recorded their weights. So you note that your measurement of the waist is in inches and your weight is in pounds. And that is for 20 male subjects. We all know what we're supposed to do. When the first question reads, create a model to fit the body percentage, that is your Y, from your weight. You know what your X is, you know what your Y is. Try and feed that data into the calculator and come up with the simple linear regression equation. Thereafter, you're going to answer the question that states that, do you think a linear model is appropriate? If it's yes, explain. If it's no, do explain as well. Then, what value did you get for your slope, which is also known as your gradient? I think that is what your beta 1. Yes. What value did you get for your beta 1? And if you are to interpret that to a layman, what would you say? The next question is your model likely to make reliable estimates? And if it is, why? If it's not, also state the reason why. Then what is the residual for a person who weighs 190 pounds and has got a 21% body fat? What model would a model that uses the person's waist size be able to predict the percentage body fat more accurately than the other that uses the weight? Create that model. So I am expecting you to come up with 2 models from the questions that you've been given there. And then after, we're going to make a comparison of the 2. So what you are simply doing is the first part of your simple linear regression, where you are just fitting your y hat is equal to beta naught plus beta 1x for 2 models. And then you're going to answer the rest of the questions as to the outcomes that you're going to get for those. Which means to say that in our next lesson, we are going to tackle the solutions. And then after the solutions, I'll just give you operational definitions for your regression analysis. Because of the results that you get, we will try and feed this into our multiple linear regression. And then you see the importance of why we started off with our STA304 and now transitioning into the 304 part. I think